Thanks everybody for joining today's Wallarm Innovation Insight. I'm Kevin Broughton, Director of Product Marketing with Wallarm. I'm here with Tim Erlin, who is our VP of Product. And today we're covering effective API protection with GraphQL and API policy enforcement. So we'll be talking about positive and negative security models, how they're different, and the pros and cons of both. And we'll also talk about GraphQL, why it's growing in popularity, how the same drivers can create their own set of risks, and we'll dig into those risks in detail. And then finally, we'll talk about how to effectively protect GraphQL using a combination of positive and negative security models. And just a few items of housekeeping before we get started. We will be recording this webinar for future viewing, and we'll follow up with a link to the recording. And we can also provide the slides upon request if you'd like. And if you do have questions, please enter them into the chat, and we'll answer them at the end of the presentation as is appropriate. Yeah, I think, Tim, we are ready to get started.
Awesome. Thanks, Kevin.
All right. Great.
So,
oh, I'm sorry.
as Kevin mentioned, we're going to start by talking about some security models. If you want to flip to the next slide, Kevin.
Yep.
Yeah. So, really, we're going to talk about two security models, and these security models aren't exclusive to API security. They're general purpose security models, so they appear in lots of other disciplines, but they're really relevant to the conversation overall as we're talking about GraphQL and API policy enforcement as well.
Cool. So I guess let's get started with the positive security model.
Yeah, sounds good. So this little illustration here is intended to show you how a positive security model works. The goal here is to allow only known good events. It's important to note that in the illustration, the known good events are colored green, and those are the ones that are being let through this barrier here. And the other ones are colored gray, not because they're bad, but because they're unknown. So the key with this positive security model is that it blocks anything that isn't a known good event. That's the way the positive security model works.
Got it. And negative security models.
A negative security model is essentially the opposite of that. So rather than allowing known good, it blocks known bad. So we flipped the coloring here. You see that there are some red dots. These are things that are detected or as bad or known to be bad. Those are being blocked. And the other ones, which are no longer green, they are now essentially unknown, indeterminate. They're being allowed through. So a negative security model blocks anything that can be detected as bad. Positive security model allows anything that can be detected as identified specifically as good. So two different approaches to security. They can be applied in multiple different disciplines, as I said. We're obviously going to talk about API security primarily here, as that's the primary topic of the webinar.
Great. So I guess we can move on now to, we've got positive and negative models, both the pros and cons of each. So I guess to start with, why don't we go over the positive model pros and cons?
Yeah. So of course, anytime you have two models, you get to compare and contrast them. This is a fun 4-box grid because you've got pros and cons and you've got positive and negative, and so you can see it could be a little confusing. So let's talk through what we've got up here. We're going to start with the positive model. So remember, this is the model where you only allow what's known to be good. The pros here are I think fairly obvious. If you employ an effective positive security model, you're essentially secure by default because you're only allowing through what's good. You're reducing the risk from anything that's unknown. You could throw in the concept of zero-day attacks here. If they can't be identified as good, then they would also be blocked as well. That positive model has what we'll color as a pro here, the benefit of pushing security more in that shift left direction. Because in order to employ a positive security model, you have to be able to define what's good. Often that definition of good in the case of APIs and applications is going to come from the developers who built and designed those applications. So they get to say what's expected input from from the user, from the client, the API client or the application client, and define that up front. The positive model also has the benefit of being predictable. If you're only allowing through what's known good, you eliminate anything that's unknown or unexpected, assuming that you can define what's good in that case. And that kind of assumption, frankly, brings us to the cons or the challenges. Because if you just read those pros, you might ask yourself, like, why wouldn't you always implement a positive security model? Well, there are some downsides. That positive model requires more time to set up because it needs that understanding of what is legitimate behavior defined up front. So you can't implement a positive security model without defining what's known to be good and excluding everything else. That definition takes time and can be frankly challenging in many organizations for applications and APIs and other disciplines as well. And that positive model can also be overly restrictive. So if you can't effectively define every single thing that's known, good, or expected, or that should be allowed, then you end up blocking legitimate activity. So that can have a business impact. It's very difficult from a business standpoint to employ that positive security model without some risk of blocking legitimate traffic.
Got it.
And then there's the maintenance around changes. So if something in the application changes, if there's new behavior that should be permitted, you have to have that rapid response to update those allow lists in order to accurately behave in that positive model as well. So pros and cons for the positive security model. We of course have the same for the negative model to look at as well. On that negative model side, for the pros, you've got a faster time to value with a negative model. If you're deploying something that blocks things that are known bad, as soon as you deploy it, it can start blocking bad traffic or bad events. So fast time to value is important there. I tend to argue that the negative model is more business focused. You could choose a different term there if you like. The point is that it favors availability of the application or the service over blocking anything that's unknown. So in that sense, it's more focused on the successful operation or the availability of that application than the positive model. And of course, there's a lower maintenance there, at least for the end user, because you don't have to change it when the specs change. You update your application, and that negative model continues to operate, blocking things that are known to be bad. On the flip side, we should talk about the cons, of course. The con for the negative model is it only really protects you against threats that can be detected as bad. So it could potentially leave you exposed to things that it can't identify as bad that are in that sort of unknown category. It does require updates to detect and prevent new threats. So those updates might not require much effort from the customer, from the user, but somebody has to put in the effort to make sure that whatever tool is employing that negative model continues to be effective at identifying bad events or bad traffic. And then it can have a higher operational burden because it has to look at everything and analyze everything that comes across whatever that control plane is, that barrier, in order to determine if it's malicious. Whereas the positive model only has to say, is it good, and pass it through and just block everything else. So there can be a higher operational burden there on the negative model. Now, if you're looking at this and wondering which one is better, there's a reason that the two don't weigh out with a clear, obvious choice, because they're both applicable. So we're not here to define that you should always employ a positive or always employ a negative model. What we wanted to do is essentially lay out the benefits, the pros and cons for both, and then talk about the applicability of the positive security model for two specific use cases within API security.
Got it. All right. Let's see here. So I guess that brings us to the second part of this, which is to dig into GraphQL before we actually look at applying the models. So we'll kind of move on to the next slide here. So,
yeah, go ahead,
yeah.
Kevin, sorry.
I was just going to say, GraphQL has been out for a while, but it's getting a lot of attention recently. So I'll hand it over to you to talk a little bit about why that is and the prevalence of GraphQL and why we're seeing more of it and more interest around securing GraphQL.
Yeah, it's interesting. In preparing for this this webinar and also the product work we did behind it, we obviously looked at the usage of GraphQL in the market, and there's a lot of anecdotal conversation about how GraphQL is growing in popularity. That's a pretty common position for people to take. So we looked for some data on that, and say, why are we talking about GraphQL with customers? And GraphQL is not new. I think that's important. So this this last Postman State of the API report, which is nice because it produces this graph for me, put GraphQL at number 3 in terms of API technologies. And that was a change from the previous year. So there was growth there that was notable, and people looked at that and said, well, GraphQL is growing in popularity. It's overtaken SOAP, moved into that number 3 position. And I think that's absolutely valid. But I also wanted to look at the history a little bit. So on the next slide, another benefit of that Postman State of the API report is that there are previous versions of it. So if you go back and look at the previous versions where they did very essentially the same graph, one of them was slightly different in terms of the questions it asked, but they then stuck with this one view. GraphQL has been around for a long time at that number 4 position and stayed pretty steady in terms of the percentage of respondents who said they're using it. So, it's interesting. I didn't plot out the SOAP number, but I don't know if it's that GraphQL usage has actually increased or the usage of SOAP has decreased, moving GraphQL up to number 4. But the percentage of organizations using GraphQL has been fairly steady with some growth over the last 4 years. And so this is a technology that you're going to find in a lot of organizations. Yet when I talk to customers, I even talked to a customer today who isn't using GraphQL and said that they're planning to. They expect it to happen in the future. So there's an anecdotal position that GraphQL is growing, and the data shows that it's certainly prevalent. 2 other data points to include here. Google identified GraphQL as one of the 7 top trends in APIs last year, 2023 as well. And then there's a Gartner estimate here that more than 50% of enterprises will implement GraphQL by 2025. So when you put all of that together, GraphQL seems to be fairly important and something that's worth addressing from a security standpoint as well. And most organizations, I think, would know if they're using GraphQL, but it's entirely possible that you might not. So it's worth looking into and asking internally if it's a technology that's in use or under consideration.
Great. Well, I guess let's dig into some of the differences here between GraphQL and REST APIs that maybe people are more familiar with.
Yeah, so we talked about GraphQL, but we didn't really talk about what makes it different or why it's useful and growing in usage. So hopefully folks on this call are familiar with REST. Maybe they're familiar with GraphQL. So apologies if I'm digging into the basics before we get to the details. But you can see an illustration here of what is essentially the same API interaction. And on the REST side, you have multiple endpoints and multiple calls, 3 of them in this case, to get the information that you're required. So you've got to hit a user ID endpoint, a user posts endpoint, a user ID followers endpoint to get that data. GraphQL is structured so that you can get more data and more complex data with a single request. And so in that example, you can see that the query, which is what you're submitting into GraphQL, can return all of that data that you got from the 3 requests, separate requests with REST API in one request and response. So it's designed to allow more complexity in terms of how you query and interact with data. And it's also designed to reduce the number of requests and responses that you have to use to get to the end result that you're after in terms of data as well. So there are clear advantages for GraphQL, especially in data-centric applications, and that's part of why it's growing in terms of popularity for sure.
And I guess that kind of leads us to the next part of this, which is, what are the drawbacks?
Well, of course, because anytime there's a new technology that's growing in popularity, attackers tend to follow that popularity as well. So the evolution or the growth in GraphQL usage certainly brings along new threats as well. And it's really interesting. We've been talking internally a lot about how API security in general is being driven by the call it the rapid pace of innovation. There are lots of new technologies that are being developed. It's almost a snowball effect. The more tools that are developed, the more new technologies that are developed, they kind of snowball in terms of availability of new things to try that make your job easier as a developer or more effective, or allow you to ultimately deliver deliver products faster. So developers are delivering faster than ever, and they're being pressured by the businesses they work for to do exactly that. And the security teams have to try and keep up with that. They have to stay abreast of the new technologies that are being used and certainly deployed within their organizations. And that drives that growth in the threat landscape as well. And I think the term threat landscape is an important one, or attack surface. They're both good terms, because what we're seeing with the adoption of not just GraphQL, but also the technologies supporting it, is that expansion of attack surface and the corresponding threat landscape, based on that attack surface.
Cool.
And that's a key component.
Great. Well, so let's take a look at what that looks like. I mean, how has this actually impacted organizations in the wild?
Right. So it's all well and good to talk about the potential threats that are out there, but it's always useful to bring that back to a little bit of reality with some examples or some actual events or vulnerabilities that have occurred. So this is a GraphQL vulnerability in Zendesk and specifically Zendesk Explore, and it is essentially a SQL injection a vulnerability, or a vulnerability that exposes the product to SQL injection with an execute query call via GraphQL. And ultimately, the impact here is that attackers were able to access, gained unauthorized access to customer data, to tickets, to conversations, and other data. And so this is an interesting one because it's a combination of both SQL injection, which is a well-known, well-understood attack. We saw that with the MoveIt vulnerability and incident that occurred, affected something like 60 million customers, and that was SQL injection. But SQL injection also applies to GraphQL. So old kind of threat with a new technology still relevant here.
Right. And here's another one. Obviously Meta's huge, and this is something that is a massive GraphQL attack. Let's dig into that a little bit.
Sure. Yeah. So GraphQL, the exploit here exposed 30 million customer accounts to takeover. There were actually multiple bugs here in this view as capability that they had exposed. It allowed for escalation of access and generation of access tokens for the accounts that were being looked up, and then the attackers could log into those accounts with the access tokens that they had generated. And as I noted, the impact here was 30 million Facebook users and account takeover of those accounts. And account takeover is a huge issue that people worry about, and it applies to GraphQL as it does to other protocols as well. So a clear incident with GraphQL in particular.
So let's dig into the actual threats. Talk a little bit about what some of the things people need to look for with GraphQL and GraphQL protection.
Yeah, and I think we took those couple of examples, but I want to bring it back to like the top threats that people should be worried about with GraphQL APIs, and they're listed here, right? You've got the traditional input validation types of attacks, but applied within GraphQL. So SQL injection is a good example. It's a pretty understandable example, but it can also occur inside of that GraphQL protocol. And then GraphQL also has some exposure to denial of service and these batching attacks that we'll talk about in detail. And then finally, there are a couple of things in the GraphQL protocol that support information disclosure as well, and we'll talk about those in some detail as well. So those are the top three that we're going to talk about in terms of GraphQL threats.
Great. So let's start with various support formats.
So as we're talking about GraphQL, you've got to make sure that whatever tools you're employing to protect against these threats support the breadth of the protocol. So that means that they have to look at both the post and the get methods requests that are coming in, because GraphQL supports both of those, and then the content types as well. So GraphQL can be flexible in terms of that content type. You're probably going to expect that JSON is probably the most common, but the other ones are important as well in terms of being able to support evaluation of GraphQL requests and responses. So I just wanted to include that up front because I think it's important context for us as we look at the specific threats.
Right. And query complexity is the first threat that we'll talk about. So let's dig in a little bit on that.
Yeah, so we talked about in the pros and cons. No, we talked about in the explanation of the difference between GraphQL and REST that one of the benefits of GraphQL is that it lets you do more in a single request. And that's great. That's powerful from a functionality standpoint, but it also lets attackers do more in a single request. So GraphQL supports this idea of nested queries where you can create a single request with lots of queries nested together into that. Essentially, as deep as you want. And the problem with that is that it generates hugely complex requests that the GraphQL application or GraphQL server then has to process. And it can create a denial of service condition if the attacker creates queries that are so complex that they tie up resources. And this is something that attackers are interested in doing if they want to impact an application or if they want to create that denial of service condition. You can absolutely create hugely complex nested queries there. And there are some countermeasures that can be employed here. Most of them are around setting up thresholds, total query size, the size of specific values, the allowed query depth. All of those can be tuned as thresholds to help prevent a denial of service from an overly complex GraphQL request, including nested queries. The reason that it's important to think of those as thresholds, and this is a theme that will show up throughout the different threats. The reason it's important to think of those as thresholds is because the applications are different. So you may have situations that require or are intended to support nested queries to a certain depth, and it may differ depending on the different applications that are being built and deployed. So you need to think of those as thresholds rather than just there's a clear indicator of what's bad that you should be detected and blocked, if that makes sense.
Yeah. And is something like that difficult for an attacker to actually pull off?
No, I mean, it's not difficult for the attacker to pull off. The creation of a nested query is relatively easy. Identifying a specific nested query that's complex enough or that exercises a particular application in a way that causes a denial of service can be tricky, but it's exactly the kinds of things that attackers spend their time doing. And of course, understanding that application and what its schema looks like gives them a huge advantage in terms of constructing that kind of a query. And we'll come back to that in one of the other threats.
Oh, great. Okay. All right. So now we got batching attacks.
Right. So we talked a little bit about this in the one of the previous slides. One of the benefits of GraphQL, again, different from a nested query, is the ability to batch multiple separate queries into a single request. So this is similar in that you're doing more in one request and one interaction, but here it's about multiple separate queries versus one long nested query. And then there's another concept that I think is important to include here that GraphQL supports, which is the creation of aliases, so that you can actually, this is a benefit for the developers or the clients of the API. If you're repeating a query against a particular object, or you can alias that so that it's easier to parse the responses essentially. But both of those things, the aliases and the batching, also give that opportunity to attackers to overwhelm the service or create overly complex, overly expensive queries and interactions that drive a denial of service condition. And the countermeasures here are, again, essentially thresholds, right? Setting up a threshold for the number of batched queries you're willing to support or the number of aliases you're willing to support in a particular query. That's, again, where you would look to limit the attacker's ability to create that denial of service condition.
Cool. All right. And then information disclosure. So here's our next one.
Right. So last but not least for the threats to talk about is these two information disclosure conditions. So GraphQL supports two types of queries essentially that are not for the data itself. Introspection and debug are the two that are there. The introspection query gives you that schema, so it tells you what the GraphQL server supports or GraphQL application supports in terms of fields and data that you can query. And then debug is obviously for debug information. The reason that the introspection, I mean, both of these expose potentially interesting data to an attacker, but the introspection query is the one that I said we'd come back to. Because if you're trying to create an overly complex query, either nested or you're trying to batch queries together, or you're trying to generate basically any kind of query, having that full schema that the introspection query provides is incredibly useful to you as an attacker. So you can then use that information to carry out a further attack or to optimize your process for creating that kind of an attack. So that information disclosure is something that's important to control, in your environment. And this is a case where you have to make a choice about whether you want to allow or block these two types of interactions, introspection queries and debug requests. So you can block them, you can allow them, you can do that, on different applications. You can do it based on source, so that different individuals or different sources have access to them. But it's important to understand that those things are part of the GraphQL environment and that they provide information to attackers and are a significant threat, in your GraphQL environment.
Great, cool.
So yeah, we've talked about those three key threats. The one that we didn't spend a lot of time on that I actually want to bring up before we move on to the how Wallarm can help is just a reminder of the what we had labeled in the previous slide as the injection, SQL injection as an example, but that GraphQL itself as a protocol, it also provides the opportunity for essentially all of the other types of attacks that you might think of for API security. So SQL injection, cross-site request forgery, path traversal, these kinds of attacks can occur inside of GraphQL or in a GraphQL request, but in other parts of the request that aren't specific to GraphQL. So when you think about the threat model for GraphQL, it has to include the API attacks that you have to worry about everywhere else, plus the ones that are specific to GraphQL, the protocol itself. And I think that's a key component to keep in mind.
Very good. Thanks for adding that. So I guess moving on, we talked a little bit about positive security models. We've talked about GraphQL and some of the unique challenges it can pose. But obviously, none of that matters if you can't execute on an actual game plan. So it's part where we talk a little bit about how Wallarm can help and how you can take action. So I guess let's start with the GraphQL security policies.
Yeah, so this is, this webinar is a product innovation webinar. And our goal here is to ultimately talk about the product features that we've implemented in order to address that threat environment. So all of that information about the the growth and popularity around GraphQL is targeted at explaining why we chose to build a capability to help defend against those attacks, and to explain what we've actually built. So for GraphQL, we've implemented the ability to apply a GraphQL security policy in your Wallarm environment. For those of you who might not be familiar with Wallarm, the key component here is that Wallarm is focused on processing and analyzing traffic, detecting and blocking attacks in that traffic, in API and application traffic. And so we've implemented this ability to create rules that implement that specific GraphQL policy. So here you can see that you can set specific thresholds, and I talked about thresholds in the previous slides, specific thresholds for the maximum total query size, maximum value size, that query depth that we talked about for the nested queries, the maximum number of aliases and the maximum number of batched queries. Those were all aimed at preventing that denial of service condition that we talked about. And then you can also enable or disable both introspection queries and debug requests as well. And then part of what Wallarm provides is not just the ability to set those thresholds, but the ability to specify when and how they're applied. So you have the ability to filter that rule very specifically to apply to a specific application or a specific part of an application in your environment, or even a specific content type if you want to go down that path, so that you can create specific GraphQL policy rules that apply differently to different GraphQL applications in your environment. So if you're an environment that has that really is invested in GraphQL and has deployed it in multiple applications across multiple endpoints, you can create different policies for each of those as needed. And then whether or not the rule actually blocks or just monitors violations of that policy is dependent on the configuration of your Wallarm platform. You can configure the Wallarm platform to behave differently in different scenarios, to either block attacks or simply detect them in monitoring mode. Or there's a gray listing mode that lets you choose for it to only block certain types of attacks, but monitor otherwise. So there's lots of flexibility around how that gets implemented. And that GraphQL security policy is intended to work in concert with all of the other API attack detection that we provide in the platform. So when we talked about the other types of attacks, you can see some of them listed here: SQL injection, SSRF, etc. That those types of attacks are also detected because of our ability to analyze the GraphQL traffic as well. So providing both that negative security model and also then the positive security model of specifying what's allowed in the environment there as well.
Cool.
So yeah, I mean, we've talked a lot about GraphQL in part because it's interesting and it's new, but I can't help but point out that GraphQL is still number 3, and at number 1 in this state of the API report is REST. So it's a totally valid question to ask. Well, that's great for GraphQL, but what about REST? What if I want to apply this positive security model to my REST APIs? And so we've also added the capability to do that as well. And that's done with our Open API specification enforcement. So again, we'll go back to the Wallarm platform. Part of what Wallarm does is it performs API discovery based on that traffic analysis. It identifies the APIs and endpoints in the environment, and then it can also produce an Open API specification that you can download from the platform based on the traffic that it's seen. Of course, you might be producing those Open API specs as part of your development process as well. So regardless of whether you produce them yourself and you have that process really dialed in, or you're using a tool like Wallarm to produce those specs based on traffic, the starting point for Open API specification is that Open API spec or Swagger document, if you prefer that term.
Cool. All right.
And then the way this works is that we give you the ability to upload that specification either from our discovery or on your own. You can actually point, if you want to, you can point to a URL and keep that specification up to date automatically. And then we do 2 things with specifications actually. So the feature that already existed before was this rogue API detection. So we'll compare the API specification to the traffic that we've seen and what we've identified, and we'll pull out for you shadow APIs, orphan APIs, and zombie APIs. Those shadow APIs are APIs that exist in the environment but not in the specification. The orphan APIs are the opposite, so API endpoints that exist in the specification but aren't seen in the environment. And then the zombie APIs are actually a changed state. So APIs that were in the specification and then were removed from the spec in a new version, but never removed from the environment. And all of that rogue API detection is really about giving you the ability to better govern that connection between the API specification and what's actually deployed in your environment. The API policy enforcement can use the same format. So you upload a policy, you choose where to apply it. So again, you have that filtering capability, and then you choose what types of events you want to block or monitor or just ignore, to not track at all. And those are the options specific to each policy that you upload. So for example, you can, this example here will block any request to an undefined endpoint. So if you just want to create a policy that says, look, we're going to have lots of change in our environment in terms of what the endpoints can do, but the endpoints themselves are very stable, you can create that blocking condition there. In this case, we'll monitor any requests with an undefined parameter. And I think if I remember correctly, the actual next slide has that example. So we'll come back to it, but that undefined parameter is the option. for that one. And then you can also do the same thing with endpoints without a required parameter. So if the spec requires a particular parameter and it's not present, endpoints with an invalid parameter value, if you've specified what those values should be in the spec, endpoints without an authenticated method, or an endpoint with invalid JSON. All of those are optional attributes that you can enforce from the Open API specification. And then all of that produces essentially an attack event inside of Wallarm. And then you can use all of the Wallarm platform capabilities like triggers to do something with those events, whether it's generate a notification or kick off some automation. You have the ability to take action based on those.
All right, now we'll move on.
Now we'll move on to the example. So this is the example of an undefined parameter event from the Wallarm console. So you can see here that we've got the data type of undefined parameter, or the event type of undefined parameter. The payload is just data. And if you look down at the bottom, you've got the actual request. And you can see that there's, in that URL that was requested, there's a parameter called data. And there's also a little explanation above that that says this request contains a parameter that is not in the specification, and points you back to the particular specification that was used. So you've got that connection back to the specification in this case, and a clear explanation of why we raised this event, in this case in monitoring mode, so we're not actually blocking it, but as an example of an event for the undefined parameter API specification violation, if you will.
Got it. All right. So tell us a little bit about using both.
Yeah, so we started off this conversation with an explanation of the positive and negative security models, and we went through the pros and cons. And I said, there isn't a clear winner, and that's intentional. You might be tempted to think that one of the two models is just flat out always better than the other, but the reality is that a best of both worlds approach is really the optimal stance to take. In any case where you can effectively define what's good, you're going to have better performance, security performance at least, in only allowing the known good items through. But the reality of most organizations is that that's either difficult or impossible to do in all circumstances, and that negative security model is really a requirement. And so when you can put them together and employ the negative security model to detect and block anything that's a known bad, and the positive security model to allow through the things that are known good, you're really getting that best of both worlds benefit. And I think that can be challenging, and it doesn't mean that you apply both of those models everywhere in your organization, but picking and choosing where to apply which model can have direct value and benefit for the organization.
Got it. And I'm going to jump ahead here. A question came through, which was pretty straightforward. Isn't a positive security model always better?
Well, so I think we were just talking about that. The way I would put it is that in an ideal scenario, the positive security model is always better. If you can actually define explicitly, clearly, 100% of the time what's known good, and only allow what's known good, that's great. It's foolproof in that sense. The problem is that the positive security model runs into reality, and that reality is, a complex organization, difficult to deliver, difficult to achieve development deadlines, a business that needs to run, a changing environment, and then in that case, it falls short. So it really is a matter of having both be the best of both worlds.
Yeah, great. All right.
Yeah. And I think we've got some other questions.
Yeah, we do. And so I'll just throw this up here. This is our next webinar. It'll be a best practices checklist for securing APIs and applications using a CISO's approach with Stefan Ilian, one of our co-founders, and Tim again. So feel free to register for that. But we'll get back to the questions here. So this one came earlier. This is around GraphQL, and I'll paraphrase here. But what's the difference between introspection and debug queries?
Oh yeah, okay. So I touched on that a little bit, but not in much detail. So as I said, the introspection query is really giving you the schema that GraphQL application supports. So it tells you what fields you can query and what parameters you can pass in those queries and that kind of thing. The debug is a tool really for developers, those debug requests, and it produces essentially debug information. So if you're trying to figure out why your query isn't working or what's wrong with your application, you're going to use that debug information. You might get log data back as an example. You're not going to get that type of information from introspection. From introspection, you'll get the schema that's supported. And of course, both of those are useful for developers, and both of those are useful for attackers as well.
Great, great. And then here's another one. So you mentioned REST and GraphQL, but what about gRPC? How do you protect against attacks with that?
Yeah. So do we want to flip back to the slide for the Postman State of the API report slide? You've got gRPC down there. I don't know what it is, number 5 or 6, something like that. So gRPC is an interesting protocol because it too is on I think on a growth trajectory, at least anecdotally. And for those of you who aren't familiar, gRPC is a streaming protocol. So it's designed for more real-time applications where you need that streaming aspect, as opposed to GraphQL, which is very data centric. And I think you could do a whole webinar about gRPC as well, but it definitely is a protocol that's important. If you're using gRPC, there are definitely attacks that are relevant. And it's also a protocol that Wallarm supports in terms of attack detection as well. So if you want to have a conversation about gRPC, we're happy to do it, but I won't take over the GraphQL webinar with the gRPC conversation.
Right on, right on. So I'll move back to the QR code there, and then moving the screen. There may be some other questions in the Q&A that I can no longer see.
Well, I can see them, so why don't I pull them out here?
Great.
So I've got 3 questions in there. The first one is, can you please also cover shift left API security pre-production? Yeah, I can talk about that a little bit. I mean, in this particular session, we've talked primarily about detecting and blocking attacks, or the positive security model, so employing policy at that detection and blocking layer. But there's always value in removing risk from your environment before you've deployed applications to production. So that's where things like API security testing come into play. And there are a couple different ways that Wallarm can support testing in your environment as well. That includes some clever things. We've got a tool or capability that allows you to redirect essentially production attack traffic to a non-production environment, which can be useful from a testing standpoint. But it's definitely part of the overall equation. What I do like about, as I mentioned, what I like about the positive model approach, even if it's difficult to employ, is that it does push the definition of known good left, as you might imagine, towards developer. So if you tell the developers that you're only going to allow the traffic that they or the types of requests that they determine are good, then you're putting them in a position of defining that known good, and that can be a pretty powerful exercise for collaboration between security and development as well. So hopefully I answered that one. There are 2 more here. Let's see. In the negative model, if we entertain uncertain events to come in, how can we rest assured that those are not threatening? Yeah, I mean that's one of the cons of the negative model, right? If you can't determine, to be a certain extent, it's a con of both models if you think about it that way. But in the negative model, you have events that are they're not detected as malicious or bad, but they're not detected as good either. And they could be unknown malicious events, right? So they could be zero-day attacks. And a lot of the energy that vendors spend on that negative model is building detection capabilities that are broad enough to pull in previously unknown events, but not so broad that they block legitimate traffic. So in a way, when you shift from the positive model, which puts the burden of defining what's good on the developer or the customer, to the negative model, you shift that burden onto the vendor, which is okay, but it's a different place for the burden to exist. As a vendor, we have to figure out how to detect things that are bad without being overly broad and blocking things that are good. And there's a lot of history there from the first IDS signatures that existed up to now with machine learning based, behavior based detection as well.
Great.
Okay. And then I see one more question here, unless anybody wants to enter more, which they certainly can. Yeah. let's see. Oh, I think one more popped in. So we've got two now. Let's see. API specific format related shown screen is positive or negative model as per the API specification uploaded. I'm not sure I understand that question exactly, but I think it probably refers to the API specification enforcement screen that I showed. So the way that that works is when you upload a specification, that defines what's allowed, and then you choose in that configuration screen whether you want to block, monitor, or ignore any violations of that policy that you've uploaded. So that's the way that works.
Yeah, it looks like we're getting more questions.
Cool. I like questions. They're good. Although this one I'm not sure I can answer. Can GraphQL be used for inventory management system? Can GraphQL take place in DB2 and MF? I don't know. I mean, you could build from an inventory management standpoint, you could certainly build a GraphQL application specifically for inventory management. I don't know if there's one that specifically exists, but you could. I'm not sure about the DB2 part of that offhand. So the next one, for the batch query limits, say you set a limit of 100 and an attacker does a batch query for 100, would it run 99 and then stop at the last one or not run at all? It would block the whole request if it exceeds the limit. So it's not going to run the queries up to that limit. It's going to block the request as a whole if it exceeds the limit, the threshold that you've set. And then the last item here was a clarification for the Open API specification screen, which is what I thought. So we did answer that one, I think. So that's good.
We have a couple of hands raised, but I'm not sure if there's questions already came in. If not, feel free to ask them real quickly. But just to follow up, we will be sending this out, a link to this presentation, so you can review it. Like I said, this is our next webinar. Feel free to register. And if you do have any questions, if you want to see what we're doing, feel free to reach out. There are links to schedule a demo with one of our subject matter experts on our website. We're always open to talking to you about what you're trying to accomplish and how we can help. Looks like we got another question or two.
We got two more questions. Sorry to interrupt your closing, but I love the questions. I love the interaction. Yeah, it's great.
It's great.
So the next question was, are there benefits of REST over GraphQL from a security perspective? I think from a security perspective, I wouldn't say there are significant benefits. As we've pointed out, GraphQL as a protocol has some particular risks that we're aiming to help address with the features we've introduced. Those risks obviously don't exist in REST, but you have to balance that against the history that REST has. It's a well-known, well-understood protocol that attackers are very familiar with. I think there are risks there too. So I wouldn't say that one of them is a clear winner in terms of security. They both have their use cases. Those use cases should be driven by the business needs, not by security. And then security, should ensure that they can operate as securely as possible. And a similar question along the same vein: in what scenarios should GraphQL be prioritized over REST? GraphQL is really good at, essentially sharing data. Anytime if you have an application that's very data centric, where you're going to be running, or your clients are going to be running queries that extract data in that way, GraphQL is a good protocol for supporting that type of operation. REST is probably better for more interactive operational APIs as well. And there's no reason that the end application that you're delivering to your users couldn't use both. But the APIs would be separate in that case.
Great. Well, it looks like that wraps it up. Thanks everybody for your time. Like I said, feel free to reach out if you have any questions. We're happy to help, and we look forward to speaking with you or seeing you on a future webinar.
Thanks everyone. Great webinar. I appreciate the interactions.